Hi there, and welcome to our video on equations with the variable on both sides, subtitled "The Wheels Will Not Fall Off." And we're going to do everything we can to stop the wheels from falling off this new layer of our equation solving skills here. Please don't forget to like this video and subscribe to the channel for more math help. Leave me a question or a comment. Let me know what follow-up questions you have or what you'd like to see more of. So let's take a look at our teaching example. This is an example that we're going to work with for the next couple of slides. So we have 7x plus 3 equals 4x minus 9. And what we mean by the equation on both sides is we do mean on both sides of the equal sign. I've had students in the past when I've said on both sides tell me, well, I thought you meant on both sides of, say, the fraction bar. So I want to be really explicit. When we talk about the variable being on both sides, what we mean is we have x's on the left-hand side of the equal sign, and we also have some x's on the right-hand side. Now, this is where a lot of my students can start to struggle with their equation solving, and there are a few misconceptions that we can clear up as we go through this that I've noticed as I've looked at my students' work and heard them talk about how they solve their problems. So, and this, again, this is where sometimes the wheels fall off. Like we're cruising, we got our distribution, our combining like terms, and solving our multi-step equations, and then the variable turns up on both sides of the equation, and we don't know what to do, and the car just stops. So I've mentioned in some of my other videos the importance of having a model, like a mental model for how you picture how math works and what we're doing. So we are going to use a mental model of this, remembering our scale, okay, our little balance scale, and what the equal sign means. Because what's really problematic here is that equal sign in between the x's. Previously, if you had more than one x, they were all on one side of the equal sign, and now we have this equal in the middle between the x's. So we're going to work with that, but I want you to remember what it means for things to be equal. It means that whatever is on the left is balanced out or has the same value with whatever is on the right. So if we were to take our bucket and like put stuff on either side, I'll show you more of that in the next slide, then it would balance out, okay? And that is absolutely critical to all of equation solving. So we're going to make the model a little bit more concrete here, okay? And bear with me. So we're going to have the same little model here with the equal sign, but now instead of the abstract 7x, I'm actually going to write out 7x's. And instead of a plus 3, I'm going to do 3 little plus signs. And over here, we had 4 x's, and I'm going to do 9 minus signs. And what I want you to picture in your head in terms of the mental model here is like we have a scale, like a physical scale in front of us, and we have buckets. And in those buckets, we have x's and we have pluses and we have minuses. And we're digging into the bucket and we're physically putting like a blob of x's, like 7 x's. There they are on the left side, and 4 x's on the right side, and pluses and minuses. And when we do that, our scale balances. So what our mission is here is to figure out what is the value of that x? What value of x will get this particular scale to balance? And that's the mental model that we're going to be working with throughout this lesson. Now, we're going to invoke some first grade language here. So we're going to go back to first grade for a moment, and we're going to talk about takeaways. And when you first learned about subtraction way back, your teacher might have done something like this, where you had 5 dot circles. I don't know what you had in class. And instead of using the word subtract, your teacher might have said, okay, we have 5 and we're going to take away 3. And so you would collect 5 on your desk, and then you would take 3 of them, and there we go, and take them away, and you would see, oh, I have 2 left. And after you did that for a little bit, then your teacher would introduce the minus sign or the subtraction sign. And by the time you get to algebra, you've been working with subtraction for so many years that we kind of lose sight of how abstract it is, that we have this symbol here, and that symbol represents a process of taking away. And so we move from that concrete into the more abstract there. Now, that's exactly what we're going to do here. We're going to take away 4x's from both sides. So bear with me. I'm going to recopy that for a second so that we can illustrate it. So we've got 7x's on the left with the 3 plus signs, and we've got the 4x's on the right with the 9 minus signs. And so we've got our scale in front of us. We have all our buckets where we got all this stuff in the first place. And now what I'm going to do is grab 4x's from this side, and I am physically going to take them away and put them back in the bucket. So there we go. Away, 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 boom, gone. Now, if this were an actual scale that was in front of us, something is going to happen. We'll tilt it this way, okay? And now, okay, we got the 9 minuses and we got the 7x's over here and the 3 plus signs. It's no longer balanced. So we have done something to one side of the equal sign, and we don't know which way it's going to go unbalanced because we don't know the value of x, but it's going to go out of whack. It's going to be unbalanced. So the question I would ask if I were doing this in front of you is I would say, okay, well, what do we need to do in order to get it balanced again? And the answer to that should be, well, if I took away 4x's from the right, I need to come over here and take away 4x's from the left. And I am getting it. It does not want me to circle 4x's. There we go. Okay, so we're going to take away 4x's from the left. So I'm going to grab my eraser, okay, and what I want you to picture is like we're picking up the 4x's off of the scale and we're taking them away. Okay, there they go. And what we are left with now is 3x's on the left with some other stuff. And then on the right-hand side, we have the 9 minuses. And what you want to notice here is that we now have x's only on one side of the equal sign. So what we've got there is 3x plus the 3. Here's the equal sign. And over here, we have the minus 9. So we've got, bring it back into the algebra from there, okay? And so that's how we got it consolidated. Now, now we're left with an equation like those we've seen before. And math, I'm going to reiterate this a couple times in this video. It is so important that you do not jump into the deep end. So with learning algebra, you can't take shortcuts to get to like the answer in this advanced math. You've got to go through every single step. So if you are cool with everything I've just done, okay, you're like, yeah, I got this. We like took away the 4x's. I see how that's balanced. I see the importance of the equal sign, all of that. And now we start to lose you. I want you to go back and check out my previous video on multi-step equations, okay? And just go back and patch that up, and then you can resume this video right where you are. Just don't shortchange it. Now, here we have our two-step equation, and I'll try to vary throughout this video the way that I'm showing the work. So one of the ways you can show that work is notice that you are adding 3 to both sides, and you might say, well, I can undo that by subtracting 3, and you could subtract 3 from both sides, again, keeping it balanced. 3 minus 3 is 0. And 3x plus 0 is just the 3x. And then over here, you might be okay with the subtraction, or you might want to change that subtraction to plus a negative. So -9 plus -3 is -12. I find that my students do make fewer sign errors when they do the plus negative, because they're not tempted to say 9 minus 3 is 6. I get that a lot. So if you have -9 plus -3, we are a lot more likely to land at the -12. And here, We have multiplication, so we would undo that with division. 3 divided by 3 is 1, and 1 times x is x, and -4 divided by 3 is, -12 divided by 3 is -4. I'm jumping a little bit ahead of myself. And so that is our solution. Please make sure that you understand why things cancel. If I were to ask my students, what's happening here or what happened to the 3's, I would get, oh, they canceled, and here, oh, they canceled. But they cancel for different reasons. These ones cancel because +3 plus -3 is 0, and 3x plus 0 leaves you with the 3x. These 3's cancel because 3 divided by 3 is 1, and 1 times x is x. So make sure that if you are not showing those steps with the 0's and the 1's, that you still know why they are canceling. Because if you don't know why they're canceling, it is only a matter of time before you do the wrong operation and you subtract something that should be divided, because we're not seeing why the things are canceling out. Now, let's bring it back to the algebra here. So we're going to go back to that original problem, and I'm going to show you like 2 different ways of showing it. So the original problem was 7x plus 3 equals 4x minus 9. And the more common way kind of goes along with the illustration that I did, where we had takeaways and we were essentially subtracting. And so you can think of it as I take away 4x from both sides, but you also got to make sure that you take away 4x's from the other side. 7x take away 4x's leaves you with 3x's, and there's our algebraic sentence there. We've got 4x minus 4x is 0, leaving me with just the -9. Okay. The other way you can do it, and there are advantages and disadvantages here, is you can do this with inverses. So instead of saying subtracting 4x, you can say I am adding -4x, and then you have to add -4x to the other side. 7x plus -4x is 3x, and 4x plus -4x is 0. And you can see that you land in the same place. So a couple of things to note about this. Both methods are fine, okay? And if I'm honest, I typically will show stuff with the method on the left because it's a little bit more compact. It puts everything in this vertical structure, which is kind of nice. A lot of people are comfortable with it. This structure over here tends to get very long, like going left to right. So you'll notice how stretched out it is. It can also be awkward to make sure you're leaving enough room to put in these like plus negatives onto each side of the equal sign. Okay, so there's like an advantage for this one and disadvantage over here. Here's the disadvantage to this. I have found that the common method sometimes leads to confusion with combining like terms in general. Combining like terms refers to adding or subtracting things that have the same variable. And so this is combining like terms, 7x plus -4x, and we combine them and we get the 3x. 4x plus -4x, we combine them and we get a 0, which is why they cancel out. Technically, what's happening right here, where you have 7x minus 4x and you get the 3x, that isolated step there is combining like terms. However, when students look at that and they say combining like terms, I have seen this so many times. Students see a 7x and they see a 4x and they think, oh, I need to combine like terms. And then they ignore the equal sign and they combine the 7x with the 4x to get 11x. And then pick a side of the equal sign to put it on. So usually it lands on the left. Sometimes the equal sign disappears altogether because we're not really observing it. And so I've seen that a lot. So if you do it this way, that's fine. Just please don't refer to the step as combining like terms. What's happening in the step is you are subtracting 4x from both sides. Okay, so subtracting 4x from both sides, not really combining like terms. This over here is combining like terms. That might seem like I am absolutely splitting hairs and making a big deal out of nothing, but I've seen so many students make mistakes there that I know that the way you're thinking about it in your head does matter. So when you're thinking about it in your head, you're thinking, I am subtracting 4x from both sides. Do not invoke combining like terms, okay? And that's one of those misconceptions. And one of the reasons why with so many of my students, this is where the wheels start to fall off. So we want to be really careful there. Now, what about negatives? Now, this is where, for a lot of students, doing the inverses is actually going to be better. So you might see the negative 2x and think, okay, well, what can I add to this side that will make that negative 2x go away? Because we want to take away a negative, but now takeaways doesn't work as well because in first grade you didn't have any negative numbers, and now in algebra you do. so you might think to yourself, okay, well, what can I add to my negative 2x in order to get it to cancel out? And so we would add 2x to both sides. We're going to keep that 11 there. And then this is where this is like a little bit awkward. You got to make sure you have enough space over there. You've got to add 2x to the other side, 5x plus 2x. Now this is your combining like terms right there. That is 7x, and I'm going to go ahead and change that to a plus negative 3. Over here, negative 2x plus 2x is 0, and 0 plus 11 is 11. And now we have our two-step equation. So if you've got a negative 3 and you want to get it out of there, you can add 3 to it because negative 3 plus 3 would be 0. Just make sure that you add 3 to the other side as well. Here's my 0. So 7x is equal to 14. And now we would divide by 7. 7 divided by 7 is 1. And 1x is just x. And this is 14 divided by 7, which is 2. Now, the other way you could show that, if you wanted to show that slightly differently, is you can do the plus 2x and you can show it vertically, okay? And then 5x plus 2x is 7x. But what's really important is that you're recognizing, what do I need to add to this in order to make it go away? And so whatever the answer is, like I'm going to add 2x to both sides. Okay, then just make sure you add it to left and right. Now, this new skill is layered on our previous skills, and I mentioned before, I was going to harp on this a little bit. Make sure that you, like, if you don't know the previous skills, that you are checking out like previous videos. So this is distribution right here. So we want to remember what distribution is. That means we're going to do 1/2 times 4x, and that would be 1/2 of 4x. Well, half of 4x is 2x. And half of 8 is 4. What might be a good idea to do here is do that little plus negative so that the way you're processing it is half of negative 8. Well, half of negative 8 is negative 4. And that way you're dealing with the negative in the negative is being going with the 8 there. Now you've got a similar problem to the ones that we've had before. Now I'm going to click over to the next slide because and I can't come back to this one, but some of you might be saying, okay, well, I can take away 3x from both sides. And let's just finish it. We're going to take away 3x from both sides. So we can do that by adding negative 3x, and then over here adding negative 3x. Negative 2x plus negative 3x is negative 1x. Yeah, actually, I'm glad we're doing this one. And then right here is a 0. And to get rid of this, we would add 4 to both sides. And here's my 0. And this is a spot where the way that I did it, like, it's not going to cause us a problem, but my students will often like land in a spot. They stare at me like, I don't know what to do. This is negative 1 times x. So to get the x by itself, we would divide by negative 1. Negative 1 divided by negative 1 is 1, okay? And 8 divided by negative 1 is negative 8. Here's what will happen to a lot of my students. Is right here where they have 2x plus negative 3x. And a lot of times they do this because they're subtracting. instead of thinking of like plus a negative. So in their head, they end up here. They say negative x, and this line right there, they have negative x is equal to 8. And then they stall out and they're like, I don't know what to do. I know I want x. And instead, I've got this like pesky negative x. Like, I did not want this negative x here. And then they don't know what to do. And sometimes they just ignore it. And they're like, oh, x is equal to 8. And I'll just pretend that the negative wasn't there. Remember that that does mean a negative 1x. And so your solution is either to multiply or divide by a negative 1. Okay, now there are some options, and I know this video is getting a little bit long, so I'll try to keep this short. There are options, so there's not just one way that you can approach this. So looking at this problem on the left, one of the things that you can do is add the negative 5x to both sides. Okay, so I'm going to try to move this over here. So 5x plus negative 5x, and then we'll make that plus negative 4. And so we have, combining like terms, 3x plus negative 5x is negative 2x. And right here is 0, leaving me with a negative 4. And then we can add the negative 1 to both sides. And there's my 0. So negative 2x is equal to negative 5, divide by negative 2. And we know that a negative divided by a negative is a positive. So negative 5 divided by negative 2 is going to give me a positive something, and I'm just going to leave it there as a fraction. So that's one common way to do it. But one of the drawbacks to that is that you end up with a negative coefficient on your x. And a lot of people just don't like having a negative coefficient on their x. And so what they will do is this. They'll say, well, instead of moving the 5, I'm going to move away, take away the 3. I was going to say move and then change it to take away. And they'll do the 3 instead. 3x plus negative 3x is 0, leaving me with a 1. 5x plus negative 3x is 2. And then they would add 4 to both sides. So we got the plus negative 4 and then plus 4. There's my pair that gives me the 0. 5 is equal to 2x, and divide by 2. And you'll notice that we landed in exactly the same place. This is a matter of personal preference only. Some people like to have the variable always on the left. So they like to have x equals, like this just bothers them and it takes years off their life. Other people would prefer to have the x positive. It does not matter. So you can kind of look at those two different options and you decide which one makes you happy in your heart, and that's the one that you should do, whichever one you like. But you know, this is where sometimes if students are cheating and they're copying and a student starts doing it this way and then all of a sudden their work morphs to this, that's how you tip your teacher off that you copied off of somebody else, because the work doesn't quite line up and it lands in the right spot, but it doesn't line up in the middle. So here's your general plan. We're going to summarize this real fast. Simplify each side of the equal sign separately. And what we mean by that is do any distribution. So if you have distribution going on, so you got your equal sign and you got some stuff over here, if you see some distribution, okay, you're going to go ahead and you're going to do that distribution. And then combine any like terms. And remember what combining like terms are. So you got some other stuff. You got a 2x plus a 3x over here. And you're going to go ahead and do the distribution. And you're going to combine your like terms. And you keep each side of the equal sign separate. Don't mess around with doing stuff to both sides of the equal sign. Like just get everything simplified. And you should get it into something that looks like this. Okay, you might have different numbers, but like if you simplify both sides, it'll be something that looks like that. Okay. Then collect the variables on one side. You can move them all to the right. You can move them all to the left. Okay, just decide which one of these do I want to have cancel out to 0, and then pick what you need to add, positive or negative, and just do it to both sides. So you get all your variables on one side, and then solve the resulting 1 or 2 step equation. So depending on what you got, like in this step, you're going to have just a 1-step equation or a 2-step equation, and you should be good to go. That's a general plan. individual problems can look differently, and there is some flexibility with that where you might decide to divide first instead of distributing and things like that. But those are the exception, not the norm. If you found this video helpful, and I'm sorry it got so long, please give me a thumbs up and subscribe to the channel. Let me know what kinds of things you would like to see. If you have follow-up questions or comments, drop them below. Maybe I said something wrong in the middle of the video and you want to call me out on it. I don't know. Let me know what you'd like to see, and I will see you in the next video. Oh, be sure to check out the practice set. I will link that in the description box and above.